Hey everybody. So in this video, I want to focus very specifically on how large neural networks work overall, and then dive into what we don't know very specifically about large neural networks and kind of a few statements around that. So first of all, diving into large neural networks as we know them, I think if you ask yourself, and you are asking yourself, kind of what is the impetus for all of this advancement, like what is making AI blow up now all of a sudden, I think that anyone would point to a paper called Attention is All You Need that was released in December of 2017 as the impetus of what we're looking at now as far as all of this. Attention is All You Need was released by Google, and then at the very end of 2017, and then so at the 2018 is when OpenAI started developing ChatGPT, and when you start seeing the development there, and the major breakthrough for Attention is All You Need is that it was the birth of the transformer model, and then the transformer model is all throughout large language models and anything to do with deep learning and AI algorithms now post 2017 or 2018. They're all based off of a transformer algorithm, which is essentially passing information through an input layer and then having it go through a multi-step process and then passing out an output. Within this, the process, there's a few things to highlight within it is that there's multiple steps throughout the process where there's masked processes that go on. So if you look at this model of what exactly a transformer does, a transformer is in essence supposed to replicate or meant to replicate neurons in the brain. And then so the idea being that you put a transformer, and then if you put a bunch of transformers together, then you can develop a neural network. And so that's kind of this was the impetus for what we see now. And then so large language models or large neural networks are made up of multiple transformers, like multiples of what we're looking at now. And so kind of how this works, a very oversimplified process, but I think this kind of illustrates it and kind of how it works in an LLM model specifically. So you can see it that you have the input layer at the top and then the output layer at the bottom. And let's say that with the input layer, someone prompts the LLM and then they say, let's walk to the park. And then so what the LLM does is first it takes a look and it's the most prominent words. So it has some flexibility and then also some built-in instructions. So the built-in instructions in this instance tell it, based off of everything that it has, that it's going to pick up on the word let's, so that it knows that it's talking about me and you, and then park. And then it's not sure if it should if it needs walk within the equation, and then it decides that it doesn't need to and the, so those get dropped. And then once you go into that, then you go into the process where it decides, okay, so it knows exactly what that means immediately as it passes through the first layer, and then park. Park is a unique example. I could park a car. I could go to the park. There's different examples there's different meanings for park. So it has the question as it passes through this first layer, okay, I know what let's is, but what exactly is this person meaning by park? So then it takes it a step further. It looks at the context around the word park. And then, okay, park in this context, let's walk to the park. The most likely conclusion is that the person means that a park is a playground. And then so the final output layer is a response, which is, sure, which park would you like to go to? Generating a response based off of that. And then so that generation process, how that works and that flow works in general, is just this straightforward transformer process. So when everyone and anyone talks about transformers and how AI works and how large language models work in general, and then they say that it's definitively just this process, they aren't wrong when they outline this type of process and say that this is what the technology is in essence, because that's exactly what it is. So moving on from kind of the LLM illustration, and then taking a look at an illustration of a deep neural network in general, there's a part that is important to highlight, and then so this is the part where I want to go into. And so, as I said, anyone that illustrates how a neural network works as far as that straightforward transformer process, they're not wrong. Anyone who says that there are elements of this whole process that are not understandable or that are not 100% known at the moment, those people are also not wrong. And then so their arguments are coming from this, which is essentially starting from this. If we look at a deep neural network, you can see this is a 5-layer network here. And then it's got the input layer and the output layer, which we went over. And then the layers in the middle are hidden layers, hidden layer 1, 2, and 3. And they're hidden layers for a few reasons. The first reason overall is that it's a hidden layer because it's what exactly the output is going to be is probabilistic. The model is given ability and flexibility within itself to, based off of attention is all you need, to make a decision within this process and based off of these layers as to how exactly and what exactly that output is going to look like. And then so when people say that it's not 100% known exactly how it functions, what they're talking about is what is going on within this process of these hidden layers specifically. And then there's nuance to this argument as well, and I can hope to portray the nuance here as well as I can. So if you start with a input from the input layer and then you have it go through all of the layers to the output layer, you can use math to come up with the probabilistic calculations of what the end result of the output layer should be, and you can mathematically map that out. What happens, and the discrepancy is that the math doesn't always play out that way, and I'll illustrate that and a little bit forward in the video. And then so that's where the discrepancy comes in, is that the math doesn't always check out. We don't understand why the math from that output layer doesn't always align with 100% exactly what it should be as we go in. So taking this and just explaining this out a bit more. So imagine that each one of these individual lines that we're looking at, and then so in this instance you can see that there's like thousands of lines, or it could be billions of lines. Each one of those lines is one of these, like this whole thing in and of itself is a line. And then when we're talking about deep neural networks, it's multiples of those, just over and over and over again, all throughout, and then all of them are weighted differently to do different things. The end result that we hope to achieve with that is essentially when we look at what we know about the brain. I think that this image here is probably a good illustration of the brain, or possibly like these. And so what we can see like within the brain is that there's neurons, like these same, like imagine that these lines are the same as those transformer lines, but then we can see within the brain that there's groupings of these lines, right? Like there's some of them like shine brighter than others. Some of them are firing at different times than others. Why exactly that happens and how exactly what regulates all of this, we don't know. And then so we're just replicating what we know about this at this point. And then so when you talk about neural networks, you can see that this is from the Getty images of AI nodes, and then you can see that it's often what the attempt is to make this a simulation of, as best we know, of like what like is going on in the brain. So the same thing where you have all of those lines and those interconnected networks and those nodes, and then you can also see that some areas are firing brighter than others. Like there's more clustered areas than others within like what's going on there. And then so diving more specifically into this on a more academic level, I just wanted to kind of just point out and then give like kind of just a reference for what I'm talking about with regards towards hidden layers and how they operate and within neurons. And then so this is from an article, just says hidden layers are the secret sauce of your network. They allow you to model complex data that, thanks to their nodes and neurons, they're hidden because of the true value of their nodes are unknown in the training data set. In fact, we only know the input and the output. Each neural network has at least one hidden layer. Otherwise, it's not a neural network. Networks with multiple hidden layers are called deep neural networks. The most common type of hidden layer is the fully connected layer. Here, each neuron is connected to all of the others and adjacent layers. It's not connected to the ones in the same layer. Convolutional layers are another type of hidden layer that are very prominent when dealing with images. So I think that this sums it up very clearly. We can measure and calculate and know what the input and the output is, and then if you take it, so transformers are based off of weights, right? So if you take a transformer, a singular transformer, and then you give it an input and then you know what the weights are, you're going to know what the output is. And then there's no argument there whatsoever, and nothing at all ever changes that equation. If it's a transformer, the weight is X, boom, it's going out as X. What we cannot fully, like what is indeterminate at the moment is what controls fully the decision process behind some of that weighting, like the weight adjustments when a decision is made in some instances within the hidden network, and then also those bright spots that you see, like as we look through these pictures, the places that are lit up and why they're lit up. We don't know how that works in the human brain, and we don't know exactly how that works in a neural network because we don't know how that clustering process happens, how new neurons are generated within the brain, what happens with neural connections, and how new neural connections are formed and can be formed, and then what a cluster of neurons does that are right next to each other versus a whole string and spread out cluster of neurons. So there's a lot of questions that are still remaining around the inner workings of this that mean that we still have questions with regards towards this. And then so with that, anyone that says that it's a mathematical equation that's 100% solved, I think that they are speaking out of turn when people make those statements, and I don't think that they can actually be supported. And then so the last piece of evidence that I'd like to leave on to solidify this and this particular argument at the end here is what we're looking at here, which is a paper that and a study that was done where OpenAI used ChatGPT-4, and then it was an attempt to model and map out ChatGPT-2's brain, essentially. And even this article, I think, does a poor job of illustrating this out, and it's one of the reasons why I decided to make this video very explicitly as I am, because I think that people are framing this issue wrong. Like, this article starts off, and at the very beginning, how it frames this is that that ChatGPT-4 was actually fully able to map out and understand how ChatGPT-2's brain is working in this instance, but that's not the case. If we look at the step 3 here, this simulated versus the actual, what we can see is that in pretty much only 1 out of the 4 instances that we're looking at, was there any sort of correlation whatsoever between the simulated the simulated input and what was expected as far as the actual, and then it's even in that it's a light correlation. You can see that like the color darkness of the simulated versus actual is where it's at, and then I mean pretty much like only Batman so it's like literally like the only thing that it's simulated out as far as ChatGPT 4 when it was attempting to guess what ChatGPT 2's brain essentially would come up with as far as the output within prompts. And then you can see very specifically here is this last one, it got it completely wrong. It did not know what ChatGPT 2 was going to respond to with that prompt at all. And then so what this is showing within this is that we have no idea whatsoever as to how exactly or what exactly the output will be on any given prompt at any given time, which is kind of the big when there's question marks with regards towards explainability and anything around AI in those senses, that's what people are referring to in the arguments that they're talking about. I hope everyone likes this video. Please like and subscribe if you like this content. Thank you very much.